Hi girls, virtual learning, here we go. We're going to talk about ATP a bit more and kind of go into a bit more detail there with creatine phosphate as well. So we're on 3.3.4 all the way down to 3.3.7. And then I'll do another session, 3.3.8 all the way down to 3.3.11. That takes you to the end of this unit. So let me know how you're feeling if I need to add any more. Okay, ATP. What is ATP? Why do we need it? Thinking about energy, okay? ATP is energy. Where do we get it from? We get it from food, okay? So rather energy comes from macronutrients, okay? Oxidation, so the oxidation that occurs funnels the energy rich compound, which is adenosine triphosphate, ATP. The potential energy within this nucleide, okay, molecule powers all of the cell's energies requiring processes. Everything, every biologic process that your body needs, ATP will give the energy for it. So we've got glandular secretion, so your glands, digestion, nerve transmission, okay, those nerves need energy. Muscle action, we know that, that's an easy one. Circulation, so the heart, the respiratory system. Tissue synthesis, the energy to build new cells, new tissues, needs to come from somewhere, and that's ATP. So the structure of ATP, the energy currency that builds, that powers all forms of biologic work. That's quite interesting. So two major energy transforming activities that ATP gets up to. It extracts potential energy from food and conserves it within the bonds of ATP. So it gets all of that energy from the food and stores it in those high energy bonds. This is all in there, ready to act when it needs to. It extracts and transfers the chemical energy in ATP to power that biologic work, okay, to allow the digestive system to use that food wherever it needs to go. Nerve transmission to allow those proprioceptors, those neuroreceptors, those chemoreceptors, all the receptors in the body. Energy. ATP is giving it the energy it needs. Okay, how does that sound so far? What about anabolism and catabolism? What are they doing? Anabolism and catabolism. How do I think about that? What do they do? Okay, so anabolism is the building blocks, okay? Anabolic state. I'm in an anabolic state. I'm building, let's say, muscle. Okay, those proteins are helping, those amino acids, building blocks to take me into my anabolic state, okay? The end product is synthesization of muscle, tissue, molecules, okay, building. Catabolism does the opposite. It does the opposite, okay? So hydrogen is going to be doing what? What is it going to be doing? It's going to be breaking down, okay? So I'm in a catabolic state. It means I'm breaking down, and let's work on the muscles because this is sports science. So I'm breaking down those muscle fibers. I'm not using them. I might have had an injury. I might not be well, and so I'm in a catabolic state. So I'm breaking those muscle fibers. How else can I break those muscle fibers? By taking my muscles past the state where of action, and they get to that point, and then those muscle fibers break. So I'm putting a lot of pressure. I'm doing eccentric movement here with my bicep curl. I've got a big dumbbell weight here. It's putting a lot of pressure on those muscle fibers, and they're going to start to tear. okay, and that's a catabolic, so they're breaking. To build them back up again, that's the anabolic state, okay? They're building blocks. Those building blocks to allow the muscle fibers to rebuild and to become stronger. How does that sound?